Hi folks, welcome back to Math with Captain Rod here. We're going to take a look at number 2 in section 14.4a as some practice with application problems. So it reads, although I shortened it up a little bit, but basically it reads the height of a triangle is 3 meters less than the length. The area is 20 square meters. Find the height and length. So the first thing I want you to do, every problem on this page, is to classify it as some type of problem. And remember, I think I gave you kind of 3 choices here, or maybe 4, but there was the distance rate problems, there was the work and jobs type of problems, and then I think I called them other, but I put a couple little subcategories under there, like geometry was one of them, and problems about numbers, and it could be, anything else could conceivably show up. So this is one of these, other. Specifically, this is a problem about geometry. It's about a triangle. Okay, if it's about a triangle, draw the triangle. Always draw pictures. In physics, I make people draw pictures for just about everything. You know how they used to say a picture is worth 1,000 words? In physics, I like to say it's 2,000. So draw it and label it. So this triangle, it has what's typically called a height, and it has what's called a base or a length. Now, which one is actually the base is kind of irrelevant. I could take this triangle and do this and call this the base, but anyway, I'm going to leave it alone. It's got a length and a height, or you could call them length and W for width or something like that. It doesn't matter. Just put a couple variables on it, all right? You could call them X and Y's if you want. All right, now we're going to use our picture here to write a couple equations. All right, it says that the area of the triangle is 20 square meters. So we're going to use this now to write an equation, this statement right here. And I'll just leave it in red. The equation for that, the area of the triangle, which is 20 square meters, I'm going to leave the units off, is equal to 1/2 length times height. I'm getting that because that's how you calculate the area of a triangle. Has 2 unknowns, which is fine. All right, now I'm going to take a look at this sentence here where it says the height of a triangle is 3 meters less than the length. I'm going to use that to write an equation here. I'm going to leave that equation in green. So it says the height is, in math, that basically means equals 3 meters less than the length. So length minus 3. And what I have now is 2 equations here. Actually we'll go to standard color now. 1 and 2. This is 2 equations, 2 unknowns. The 2 unknowns are the length and the height, and then length and height. So there's multiple ways to solve these. This one is set up really nicely for just good old-fashioned substitution here. I've got the h equals L minus 3, so that means anywhere we see h, we can put L minus 3, and I see an h right there. So what I'm going to do is take this, sub it in here, rewrite this equation. Okay, there's my new equation. Noticing it's quadratic, and that's just because of the section we're in. All right, now it's going to be a matter of solving that for L. I think a good first step would probably be multiply everything by 2. Now, at this point, you might be tempted to say, well, L is 0 or L is 3. No, that only works when you have 0 on one side. This is not a 0, that's a 40. So this has to be messed around with a little bit. So why don't we distribute that? Now, how we proceed from here, I'm just rearranging the equation. Whoops, 40, not 0. How we proceed from here, it depends on how you want to handle these. Now, in the previous examples, I used the quadratic formula. I think this one right here, I'm going to do something else. I'm going to think about the factors of 40 here if I move this on the left. 10 and 4, 8 and 5. Actually, 8 and 5 is probably going to work. Darn it. This one factors easily. I was actually looking for an example to complete the square. I'm going to do that anyway. This one can be solved by factoring, but I'm going to ignore that and complete the square on this because that's a skill that, judging by the last test, we could all use a little bit of practice with. All right. And don't anybody feel bad for that. I've noticed that people tend to struggle with completing the square, across the board. So when you complete the square, you want to leave this guy alone. You typically leave a little space here. I'm going to actually just do this. And I'm going to ask myself, what do I have to add here so that this left-hand side is a perfect square? And the way you tell is you look at this guy, minus 3. You cut it in half and square it, which would be 9/4. So right here, I'm going to add a 9/4. Now, over on the left here, or on the right here though, you've got to add one over there. You can't add something to the left if you don't add it to the right. So again, whoops. Pardon me for a moment, I have to answer my phone. Okay, I'm back there. Apologize for that here. So where were we? We were talking about completing the square. So again, let me just kind of back up and talk about this guy. What you do with that 40 depends on how you're going to plan on solving it. If you wanted to try to factor it or use the quadratic formula, you would put it on the left because you always want a 0 on one side when you're trying to solve by factoring or quadratic formula. If you're going to complete the square, you just leave it alone, like I did. And then the idea behind completing the square. Let's see, it's how can I turn this into a perfect square? And again, remember, you're trying to make it look like L minus something times L minus something. That's what the perfect square would be. And the outer and inner products have to give you the 3. So that means these have to be 3 halves, minus 3 halves and plus 3 halves. And then the idea is, what do we have to add here? And that last term there would be 9/4. That's why I added the 9/4. Again, if you don't want to think about it like this, just remember, take this middle term, like I did, -3, cut it in half, and square it. All right, 9/4, both sides. Okay, getting back to solution here. All right, so this guy now, I have designed it to equal L minus 3 halves, the quantity squared. The right-hand side is 40 plus 9/4. And I think what I'll do here is combine those into a fraction. That would be 160 over 4 plus 9 over 4, which is 169/4. Sorry about that goofy 9. All right. Square rooting both sides. So L minus 3 halves is going to equal now the square root of 169 over 4. Now, this thing right here, you got to study it carefully, and a lot of people missed this on the test the other day. This equation has 2 possibilities. This thing here, when we square it, we have to get 169 over 4, but that means this could be either positive root 69 over 4 or minus root 69 over 4, because if I take the negative and square it, you still get 169 over 4. So there's 2 solutions here. So L is going to equal, adding the 3 halves to both sides, plus or minus. Now, perfect square here, I believe that's going to be 13/4. Halves, I'm sorry, 13 halves. All right, now we're going to look at these 2 solutions. One of them is negative. 3 halves minus 13 halves is a negative number, and a triangle has to have a positive length to it, so we're not going to worry about that one. We'll take the 3 halves plus 13 halves, which is 16 halves, which is 8. And we'll just toss the other solution because we're not going to need it. It's not applicable in this problem. So the length of this triangle is 8. And somewhere it says something like the height is 3 less than the length. So the height is L minus, L minus 3, which is 5. So this triangle is apparently 8 meter by 5 meter. All right, so again, kind of overview. You read the question, kind of make a decision about what it's about, and then I want you to classify it. This was a problem about geometry. I didn't actually write it out, but I should have. Geometry. Right? Draw the geometry and label it. In this case, I guess I didn't actually write out, but I defined a variable. L is this length and H is this length. When you label it like that, you have defined variables. All right. Then look at the equation, look at the sentence here, or this paragraph, to try to write equations. The height is 3 less than the length, so that allows you to write out, I don't know where I wrote it, but right here. The height is equal to L minus 3. And then here, the area is 20 square meters. Use that to write your equation. All right. Then it's how do you solve it? Solve the system of equations. And that's going to, that will vary case by case. You can use substitution or other methods. And right? And then go through the math, solve it. Don't get in the habit of always throwing out a negative solution for problems like this. There are plenty of problems where the unknown can be negative. For example, imagine maybe a coordinate system, and one of the unknowns is the x coordinate of some object. Well, that could be a positive value, but it could be a negative value too, because x could be over here. So don't get in the habit of always throwing out negative solutions when you're working these story problems. Sometimes they'll be physically valid, sometimes they're not. Here the length is a distance that is positive, so that's why I threw out the negative solution. But again, if the unknown was a coordinate, it could be negative. You have to take that on a case-by-case basis. So hope that this video helps on how to set up some of these story problems. Have a great day.